All right, today we're going to talk about 9.2, circumference and area of circles and sectors. Now the first two pieces of information, the circumference of a circle, which is like the perimeter, the distance around, and the area of a circle, those are review. Now what's going to happen though is we are, of course, going to always be using these in new and more complicated ways, but the concept is always the same. If you have a formula, substitute in what you know and solve for what you don't. So if I tell you a circle has an area of 49 pi, what's the length of the diameter? I can solve for the radius by saying 49 pi is equal to pi r squared. Area equals the area formula. If I divide both sides by pi, I find out that 49 is r squared. That makes r 7. My question asked for the diameter, and so it's 14 units because a diameter is 2 times a radius. Now, things get more interesting when we start dealing problems like this. A circular swimming pool with a diameter of 28 feet has a deck of uniform width built around it. If the area of the deck is 60 pi square feet, find its width. So what we've really done here is we've divvied this up into a couple of areas. And we've said that the deck area, which I have labeled 1, would be equal to the whole area, the larger circle, minus the pool. And so what we are going to do, we know the deck area is 60 pi. The whole circle, the radius of my biggest all the way around circle is 14 plus d. So I'm going to have 14 plus d, the quantity squared, that's my radius, pi, minus the area of the pool, which is going to be 14 squared pi. This is going to take some algebra. 60 pi is equal to, when you expand this by foiling, you get 196 plus 28d plus d squared times pi minus 196 pi. Now notice I did just the foiling right here. Remember a quantity squared, two things. Now I'm going to distribute this pi to all of them, and I'm going to have 60 pi is equal to 196 pi plus 28d pi plus d squared pi minus 196 pi. And initially it's looking like it's complicated. But if we just keep working on it, 196 plus and 196 minus disappear. If I divide both sides by pi, I'm going to end up with 60 equals 28d plus d squared. This looks like something I can factor or do the quadratic to. So I have d squared plus 28d minus 60 equals 0. Indeed, it's going to factor nice and neat for us into those. So that means that d plus 30 equals 0. This is all review. Or d minus 2 equals 0. Well, it doesn't make sense that our distance is going to be a negative 30. So our deck distance is 2 units all the way around. So this is where our skills start to layer. That you can use an area formula, bounce back to factoring or quadratic formula, and continue to solve with the zero product property. These skills never go away. Now the area of a sector, which is a fancy way of saying part of a circle, a fractional part of a circle, can be found by the formula m. M is the central angle, remember that central angle is at the vertex, over 360. That makes the fractional part of the circle, what portion of the circle, times, this is the area. So basically, fraction times the whole circle to get the area portion. The formula makes sense. It's very simple to apply. My central angle is 90 over 360 times the area. And when you work that out, you find out that your area is equal to 36 pi units squared, or approximately 113.1 units squared. Now, a window wiper of length 20 inches goes through an angle of 160 degrees. Now, if you think about a car window, initially you think about your wipers going through this angle. If you could envision that that is actually a portion of a circle, then you can see that to find this sector area, we would take 160 divided by 360 times, that's our fractional portion, times pi times 20 squared. And that will give us the area of our sector. And when you put this into your calculator, you find out that the area here is 558.5 inches squared. Now another practical application type problem. Amy is using a sector of her circular garden for vegetables. If the area of the sector is 15.5 and the central angle is 76, what is the radius? So this is a case where I go to my formula, I put in what I know, and what I don't know is radius squared. And I'm left with something that can be solved with algebra. Now, to undo this fraction, you either multiply by the reciprocal, or you can do it in pieces. You can multiply by 360 and then divide by 76 pi. When you do all that, what you're going to come up with is that 23.5 is equal to the radius squared, which means the radius is 4.8 feet. Now, composite figures are also very real life because we very rarely encounter a nice, neat, tidy triangle, rectangle, parallelogram. So the key to these is dividing them up. Now I'm just going to copy this and then paste it because we can do this in two ways and get the same answer. I could divide it here and have area 1 and area 2, or I could divide it this way and have area 1 and area 2. Find the two separate areas and add them together. Now, you do have to do some thinking. If I make this rectangle 1 here, this side is 22, which makes this side 22. If the whole thing is 30, that makes this baby piece 8. In the same way, if it is 25 to this point and 45 to the other, that means from here to here is really 20 units. So now I have my area 1 plus area 2. So I have 22 times 45 for area 1 plus 20 times 8 for area 2, and I come up with 1,550 units squared. In this case, you would have 22 times 25 for area 1, and area 2, I still have to use my math. If it's 25 to here, but 45, that makes this little piece 20. So I'd have 20 times 30. And I still come up with exactly the same answer. So how you divide it is really a matter of what you see and what formulas you know. Now to find perimeter is distance around, and we seem to be missing a key component, and that key component is this right angle. So if here to here is 15, because I've now made a rectangle, the whole base is 22, that makes this piece right here 7. It makes this piece here 12 because this is a rectangle. And so if I call this x, x squared is equal to 12 squared plus 7 squared, which means that x is 13.9. So my perimeter is going to be 15 plus 13.9 plus 22 plus 12, which equals 62.9 units. Now to find the area of this, since this is a trapezoid, my area is 1/2 of the height, which is 12, times the sum of the bases, which is a straightforward formula, and we come up with 222 centimeters squared. Now this one gets to be kind of interesting because what we're dealing with here is a pool. So to find the area of the pool, so the area of the pool is equal to the area of the rectangle minus 1/2 the area of a circle, because this region right here is really half of a circle with radius 9. And so my rectangle is 20 times 36 minus 1/2. The area of my circle would be 9 squared pi. And when you work all that out, you end up with 592.8 feet squared. Be sure to watch your order of operation that you're multiplying before you subtract. This picture needs to be divided up into 3 pieces, and the easiest 3 pieces are right here. And these make trapezoids on the outside and a rectangle in the middle. So if I start over here with 3, 3 is 10 by 14. All the measurements are good. That makes this piece right here 20 because of the rectangle. And if I have 10 and 20 that I've used out of that 36, that makes this guy 6. Now the key with these end pieces is to remember the bases are the parallel sides and the height connects them. So area 1 is going to be 1/2 of 6 times 14 plus 20. And area 2 is a rectangle, which is just going to be 20 times 20. And area 3 is going to be 1/2 of the height, which is 10, times the sum of the bases, which is 20 plus 14. When you work those out, you end up with 102, 400, and 170. So my total, when you add them all together, is 672 feet squared. Our last example in these notes is a bit of a thinker because you have to think about how things fit together. If the length of this whole side of the rectangle is 2, and you think about that length actually being the same all the way across, that means that the diameter of each circle is 1, which means that the radius of any one of these circles is 0.5. Now here they want the radius of the shaded region, which is really the radius of, or the area of 8 circles with radius equal 0.5. And so we have 8 times each one of those circles, and what we end up with is 6.3 feet squared. If I had wanted to know what was left of the rectangle, I would subtract 6.3 from 8. So draw in some extra points and lines as needed. Use your creative thinking, and good luck with the homework.